Over here. All right, Richard.
Hello, can you hear me?
I can.
Awesome. Okay, so I'm going to talk about the Haiku Package Manager. This is the package manager that's part of the Haiku operating system. I want to thank everyone for watching. It's interesting, actually. There's going to be a theme present here that was also in the prior talk, the 2 talks prior on the an improvement for packaging. So cool continuity there. So I'm just going to do a quick introduction. We'll talk about packages, and if everything goes well, I have a demo. So briefly, who am I? My name is Richard Zach. I am a Haiku enthusiast, a software developer, and I'm a cybersecurity researcher. The point here is that I am not a member of the Haiku team, and I'm not a Haiku developer. I am just here on my own. So what is Haiku? So from the website, Haiku is an open source operating system that specifically targets personal computing. Is it inspired by the BeOS? Haiku is fast, simple to use, easy to learn, and yet very powerful. And we can see the screenshots of the two. They really do look remarkably like each other. One thing, though, if you can see on the screen, the GL teapot on the bottom right on the Haiku screen is showing 602 frames per second, which is pretty impressive because Haiku doesn't have any kind of hardware acceleration. So that's just all CPU rendering of OpenGL. So what is it? It's a single-user Unix-inspired desktop operating system. So if you're familiar with Linux, there's a lot of things that are going to be similar. Executable files and libraries are ELFs. Bash is the default shell. SSH is available. A lot of programs for Linux or other Unix OSs generally recompile fairly easily on Haiku. Haiku has standard tools, make, CMake, GCC, LLVM is there, Rust, Java, a bunch of others. And it's also important to note, Haiku is not Linux. It is not BSD. It is not a fancy desktop environment or anything. It's its own kernel. It has its own kernel. It has its own user land. It's its own thing. So it was inspired by BeOS. And a quick note there, BeOS, for those who maybe don't remember or don't know, was a company, it was an operating system made by a company called B, which was founded in the 90s by a couple of former Apple employees and VPs. And so they, of course, were heavily impacted by what macOS looked like. And so BeOS came to look very much or have a similar feel as classic macOS, with some differences, of course. However, by 2001, B ceased to exist, had been sold to Palm, and BeOS, of course, also then disappeared. However, that same year, one of the developers at B was able to rewrite an open source version of the kernel and basically kicked off the Open BeOS project. And that was later renamed to Haiku to avoid any kind of trademark conflicts. 32-bit Haiku is binary compatible with BeOS. So if you have an Intel BeOS application, it'll run on 32-bit Haiku. Of course, though, the PowerPC versions of BeOS applications are not going to run. Haiku exists solely because of its strong developer and user community, volunteer efforts, and donations. There is no corporate sponsorship. One thing that is pretty cool is that this summer it was announced that Haiku had made enough money in donations that they were able to provide a full-time job to one of their lead engineers. So we have a full-time person working on it for the first time. This summer also, Haiku was successfully brought up on RISC-V, the full desktop and everything. And there is work bringing it up for ARM64, hopefully for Raspberry Pi, a couple of other architectures. And Haiku is 20 years old. So the project was formed in 2001, and the first release was in 2002. And I believe the third beta was released this year. Okay, so some of the usual features. We have a graphical interface. There's also a command line interface for looking at packages. The packages are generally separated into application packages, development, headers and things, and source. The retrieval of packages, including dependencies, comes from a repository, and it is all architecture aware. There are quite a lot of packages in there. There's lots of popular items as well, including VLC, LibreOffice. I believe Telegram is in there, and lots more. Some of the more unique features is that the packages are mounted as read-only into the file system. And the packages can indicate with metadata what libraries or commands are present. So this allows for a little bit easier dependency managing, because now you don't have to specify for a package that what is the name of the package that your package needs. You can simply specify, okay, I need lib:/JPEG. And if some other package happens to provide that, then good enough. Of course, this also can manage or specify a version if that is needed. One of the interesting things too is that the file system is aware of the package, of the package manager. So you're able to query the attributes on a particular file, and you can indicate, it will indicate to you the source of which package is the source for that given file. And one thing that is also pretty interesting is that the bootloader is also aware of the package manager. So since the package contents are mounted into the package, into the file system rather, the files into the directories are entirely read-only. This is made possible because the package itself is compressed with equally sized chunks to make it a little bit easier to have random access into the compressed file, as opposed to compressing it all together. The benefits to the user is that the file cannot be accidentally modified or deleted or intentionally messed with. I don't think there's any Haiku malware out there, but it would be more difficult for someone to modify something unintentionally. As far as the developer is concerned, it's nice because it ensures that the files that are in the package will be present on the file system in a predetermined full path. So at packaging time, you know where it's going to be, and you know that nothing else could possibly modify the files that your package is providing. Of course, this doesn't work for every piece of software. So there is a non-packaged directory that can be used to provide other things, other libraries, other things that maybe the user wishes to install. We'll give an example about that in a minute. So because the packages are also mounted into the file system, all of the packages themselves are existing on the disk, on your drive. So let's say, for example, you and some friends are traveling, and you decide that you all brought your Haiku-powered laptops, and maybe a friend wants to use a particular program that you installed that they didn't install, and let's say you're offline. It would be easy enough to, let's say, just hook the computers together with an Ethernet cable, copy over the package files because they're on your machine, and provide them to the other person, and they can just install them pretty easily. So when you boot Haiku, usually it just goes right into the kernel and the whole boot process. But the bootloader does have an interesting option where it is able to see the prior state of the package managing system. So if you are working on something, you install an update, maybe things go sideways, you are able to just reboot the system and go back to however the package or however the system was at that time. So the prior states allow going back to how the system was previously. This also includes Haiku itself. So the entirety of the Haiku operating system is also packaged. So this is great for debugging and development. Let's say you are working on a driver or something, and maybe you get a kernel panic. You can easily just reboot and go back to how your operating system was prior to the faulty code. And from an end user's perspective, they can simply just go back to how the system was, or maybe a couple of iterations prior if need be for some software. This also makes it a little bit easier to have the ability to do development on real hardware. So if you're a Haiku developer, for example, you can develop on actual hardware instead of a virtual machine, and this can act as a way to kind of simulate the functionality of having snapshots in your virtual machine environment. So there are some metadata items inside of each package. Generally, we have the basics, the name, the description, the software license. The license information does show in the Haiku depot. It also can provide the names of the library that it provides or commands. So one of the nice things is, let's say you want to install some command, and you know what the command is, but maybe you don't remember what package it is. I've had that myself where I'm trying to install something, but I don't remember which package it is in Ubuntu or CentOS, and have to pull up some documentation to figure out, well, which package has this command. The cool thing here is it doesn't matter as long as the package indicates in the metadata. You can just do packageman install command : whatever command you want, and it will find it and install it for you. Also, if there are multiple programs that might have that same command, it will show you a pop-up and it will let you choose which one you want. So if you are going to be porting software to Haiku, you may have noticed with some of these example directories that these files are not usually in the same place. So I was tinkering the other day with QEMU in Haiku and had to hard-code a setting to say that the DNS resolve config file, it's the same one that you would have in Linux, but in this case, it's just in a different place. The other thing to consider is that the user's directory configuration files, the dot files, instead of putting them just inside of your home directory, there's a specified config/settings in the home directory. And again, since this is a single user operating system, the home directory is always going to be /boot/home. So again, if you were porting something, then you know exactly where the config file is going to be. We mentioned earlier about being able to make changes. So one of the things that when I was first discovering Haiku was that pip doesn't work too well sometimes, or at least when I was trying it. And there are workarounds, of course. But the problem is that by default, Python wants to install files inside of its lib directory. And as we discussed, that is read-only. So there are 3 ways to go about doing this. One is you could put the Python module in a separate Haiku package. And if you look in Haiku Depot, that's exactly what is done for a lot of these things. So matplotlib and NumPy and other popular packages, Python modules are separate Haiku packages so that when those get installed, they can just be placed right inside of the Python library location. The other option is that you could tell pip to install inside of the unpackaged directory, and then you could update your Python configuration to add a new directory to the Python path. And final option is you could just create a virtual environment and just work from there, in which case